definitely not leaving, so it has to stay in. It has to transform into a healthy, cognitive, and non-violent person to be able to be freed, right? On parole. Okay, that's a bad example. But you're not gonna. Okay. So you're gonna have, to get this here, you're gonna have the pyruvate malate shuttle, right? Which you wouldn't think. You're like, pyruvate and malate, what does that have to do with acetyl-CoA? But that's in the midst of it. So, okay, so we've got fatty acid synthesis, right? Okay. Okay, so you have acetyl-CoA moving into malonyl-CoA because of this acetyl-CoA carboxylase, this ACC, which requires biotin, and it requires an input of energy to get malonyl-CoA. So there's also a note that I wanted to state. Okay, so then after this, the fatty acid synthesis pathway, malonyl-CoA is going to be elongated by 2 carbons. So it's going to become 2 carbons longer. And basically what you're doing is you're making these fatty acid chains. Okay? And then you reduce, so you're making this little product and there are things off of it, whatever. Just an example, rough sketch. And so the first step is going to be adding on, right? And then the second step is going to be reducing. So these are going to move away. This is not accurate, but this is just kind of an idea of what happens. So everything's reduced. So then it's not, charged, basically, if that makes sense. So it's reduced, so it's in a stable form so that it can be stored. Make sense? Okay, so 1, add on 2 carbons to this, so plus 2 carbons, and then reduce. Okay? Does that make sense? Any questions on that before we go to the pyruvate malate? Does that make sense to you guys? Okay, so that's basically just the first part of fatty acid synthesis. So, okay. So, now, so, has anybody seen a picture of a mitochondria before?
Yes.
Okay. Mitochondria, there's the cristae, the folds, right? So this is the outer mitochondrial membrane. This is the inner mitochondrial membrane. We have to go through both of those. Outer, inner. Okay. So, and then this would be, if this is the outer layer, what is this going to be here? Cytosol. Oh, it's okay. And then inside you're going to have the matrix. Okay. Maybe I should have done that in a different color. So you have acetyl-CoA here on this side, and you want to get it to this side. Right? So you want this to go here, you want to accept this over here. Bam. Did I spell that right? And so you have a process to get that across. So citrate and pyruvate are going, even though it's called the pyruvate malate cycle, citrate and pyruvate are going to be the 2 things that go through these right here. Does that make sense? Okay. So your 2 key transporter thingy-bobbers are and if you think about it, pyruvate goes, what am I trying to say? I forgot what I was going to say. Never mind, scratch that. Those 2. Okay. Okay, so you can take pyruvate from the outer and bring it in here. This is kind of the last step almost, because what you're trying to do is take this acetyl-CoA and move it out here. So you wouldn't start here, you're going to start quote unquote here. And then, where else have you seen this reaction? Pyruvate to oxaloacetate.
Like
Gluconeogenesis,
yeah.
Good job. So what enzyme is that going to be?
PC.
PC, which stands for?
Pyruvate carboxylase.
Pyruvate carboxylase. Okay, so that's step 1. Part of gluconeogenesis. So where would this by the way, where's all this occurring?
Cytoplasm?
Sorry, larger tissue-wise. Like what organs is this happening in? Is this happening in your muscles? Liver. Good, because you cannot produce, remember you cannot produce fats in the muscles. You use them and keep, anyways. But, so this is all happening in the liver. Okay, so you have this going to OAA, and then it is going to citrate. Okay, and the enzyme for this is citrate synthetase. Okay, so what you have here is this actually coming up and binding on, and you have coenzyme ASH, which comes off. So this acetyl-CoA, which we want to get to the other side, is binding to this oxaloacetate along with this citrate synthetase and making citrate. Where do we see this reaction right here?
TCA.
The TCA cycle. So if you think about it, you're putting acetyl-CoA into the TCA cycle. You have O-oxaloacetate coming up and meeting that. This is a 4-carbon sugar. It's meeting a 2-carbon sugar, and it's turning into citrate, right? So we see this, we've already seen both of these reactions. They're just happening for a different reason at this point. Make sense? Okay, so if you get confused, I guess, on what may happen here, you're like, okay, I know this goes from oxaloacetate to citrate. Okay, what happened, like, what else happens? You'd be like, oh, well, I know that this enzyme right here is citrate synthetase, and I know that acetyl-CoA meets up with that. Oh, that's how you get acetyl-CoA to the top, because it binds here first and makes citrate. And then what citrate does is it crosses this border, these two membranes, and it ends up in the cytoplasm or the cytosol. Same thing. I don't know why they can't just come up with one word, but that's okay. So then you have, I don't want to get this mixed up. Okay, so then you go right back to OAA. Okay, so it's basically, so far, you're doing the same thing that you did over here, just backwards. And that is done by ATP, whoa, that's a really good marker. ATP citrate lyase. Okay. And what happens here is, oh look, acetyl-CoA was added on at this point. Oh look, acetyl-CoA is going to drop off at this point. So you're going to get this coenzyme A. It's a thiol with the sulfur and stuff like that. Anyways, and it binds, then it takes the acetyl-CoA off. The SH is basically just a carrier for the coenzyme A. So you know how coenzyme A is a transporter? Remember? This is basically the transporter for the transporter. So this part right here, which I don't know if you went over that or not, so I don't know if you need to know that. But so you get acetyl-CoA over here, and then acetyl-CoA increases, and that right there is how you get acetyl-CoA into the cytosol. However, now this byproduct needs to get back into here, right? So what comes next?
Pyruvate?
No, there's one step. That's the only thing that's, so this is the thing that's different. There's one extra step in the cytoplasm. Malate, good job. And then to pyruvate, which the enzymes for that are, okay. So malate, dehydrogenase, and malic enzyme. Any questions on that so far? Okay, so during this process, darn it, I wish we had a computer. Look at the stickers up there. During this process, we're bringing acetyl-CoA into the cytoplasm, right? So that's one reason or purpose of the pyruvate malate cycle, right? To increase acetyl-CoA. Okay, now we know how that happens. And also during this, there's a reaction, and I didn't bring my computer, so I can't read it. And I'm not remembering which one, but if you guys remember, which one produces NADPH? It's okay if you don't. That's okay. Just look that up. So you're going to also be producing NADPH during this process. But another way that you can produce the NADPH from this,